Hi guys, this is your favorite math teacher, DKA. If you have not subscribed to my channel, kindly go and subscribe to my channel for more content. The last time we met on the trip, we ended at looking at special angles. And today we are here, we are going to look at converting one trigonometric ratio to another. What does it mean? We have three main basic trig ratios. We have the cos of an angle, we have sine of an angle, then we have also tan of an angle. We also have their reciprocals. So the reciprocals of tan, as you know, that is cotangent. Cotangent of the angle. We also have cosecants of an angle. Then we also have seconds. And if you don't know where we got all these things from, can you visit the previous post or the previous video or the lesson, and you know how you can use this one to reduce this ones. So you based on this, use this one. And in the last previous video, I told you that you always analyze the first two letters, then you consider the next letter, which is the third letter. So the C here represents force. So meaning, if this one represents force, meaning this one is telling that the first two letters is telling that this is the inverse of force. And if you come to this one, if you underline the first two letters, the third letter is what? Sine. Meaning this one is telling that, or giving you a clue that this one is an inverse of what? Sine. This one, if you underline the first two letters, the next letter is what? Tan, which is T. So this one is giving you a clue that these first two letters give you a clue that this is the inverse of what? Tangents. So that's how. So we are able also to reduce the ratios for them. So if you want more clarification, if you want to understand, if you want the more concepts, can you visit the previous video for more understanding? Now let's start. Assuming we have sine theta of an angle, let's say √3 on 2. So let's specify. So where theta lies in the second quadrant. Find cos theta and tan theta. So, for example, they said sin theta is equal to 3 on 2, where theta lies in the second quadrant. The person says what? You should find what? Cos theta and what? Tan theta. So you have one of the basic ratios, and we are going to base on this to find the other ones, which is what? Cos and what? Tan. How do you go by it? So anytime you have something like this, the first thing you need to use what? To sketch. To do what? Sketch. So how do you go by it? So we first, of course, sketch, because we sketch by drawing our right angle triangle. Our right angle triangle, we can label it maybe A, B, C. And can put the angle theta at any place. So here is right angle triangle, which is 30 degrees. So either you put the angle here or you put it here. Any place that will be convenient or it will be easy for you. So let's put theta here. Now we are giving sine from the question that sine theta is equal to √3 on 2. Now if you apply the ratio, that when we have so the short form of sine theta, so if you want to do the ratio for sine, you know that the first letter, which is S, this is what? Sine of an angle, so sine of a certain angle. So from the first we are giving the angle to be theta. This is equal to, then the next letter is O, which stands for opposite. Then over what? Hypotenuse. So this is the ratio for what? Sine. This is the ratio or analysis for sine. So if you compare this, we compare this to compare what you have here to sine theta to be equal to root 3 on 2, you can see that the opposite is root 3. Then hypotenuse is what? 2. Now from here, we know from our previous video that opposite is the line which is facing the angle. So that way, T minus time, here is the opposite, and our hypotenuse is 2. If you have to find something difficult at locating those things, please kindly visit the previous video for more understanding. Now we know this side, so we have to look for the other side, so the length of BC. So now if you have to look for BC, it's going to be, we have had the law of what? Pythagoras, which states that the sum of the square of the opposite and the adjacent gives you the square of the hypotenuse, which becomes the magnitude of AB squared plus the magnitude of BC squared, all equal to the magnitude of AC all squared. So that's so AB is root 3, so you are going to have root 3 all squared plus BC, which is x squared, equal to AC, which is 2 squared. Therefore, with this, these two cancel this. You have 3 plus x squared equal to 4. Then, we are looking for x. So what to do is to make x squared the surface equal to 4 minus 3. Therefore, x squared equals 1. Therefore, we want x, not x squared. So we want to do is that we take roots. We take roots towards both sides. So root that, we are going to have this equal to root of 1. Therefore, these two cancel this. Therefore, we have x is equal to plus or minus 1. If you take root of every number, the answer is plus or minus 1, but we are looking for the positive one. So therefore, we conclude that x is equal to 1. Since we have found this side, now we can find what the person answered. So the person, we were told that we should find cos and tan of what? The angle. So we are now going to look for cos theta. And you know cos theta in our previous lessons is equal to adjacent over hypotenuse. So what's the adjacent? Adjacent over hypotenuse, which is equal to 1 over 2. But in the second quadrant, as we learned in our previous lesson, cos is negative in the second quadrant. So cos here becomes negative half. Then tan theta will be equal to, so tan theta, which is opposite over adjacent. So we know opposite over adjacent. So which is becomes root 3 on 1. So which is equal to root 3. But note, in the second quadrant, tan is still what? Negative. Tan also is negative. Therefore, tan also is negative. So we found cos, we also found what? Tan. So that's about the converting one trigonometric ratio to another. Let's take one more example. and try. Let's take one more example and try. So let's see. So sine A is equal to A over 17, where A is so we are giving sine equal to 8 over 17. While A is an obtuse angle, the person says phi cos theta and sin theta. But as you know, the same procedure always, we need to sketch the right angle triangle. We can label it if you want. Then I've told you, you can put, so the first time you put the angle here, so this time around, let's put the angle here. So which becomes angle A, we are given. Now, we know sine, which is what? Sine to be what? So which is opposite over what? Adjacent. So opposite over adjacent. So I have 8, then I have 17. And if you have problem with this, you can visit the previous video and you get the concept more over there. So therefore we are looking for this side. So therefore, by applying the laws of Pythagoras, it becomes what? Y squared plus 8 squared equal to 17 squared. This is going to be, to make y the subject, we need to have y to be equal to 17 squared minus 8 squared. This is therefore going to be root of y. If you take root to both sides, we're going to have roots of 2, 8, 9. Square root of 17. 17 square will give you 2, 8, 9. Then square root of 8 will also give you what? 64. So therefore we are going to have root of y squared equal to root of 225. Then these two will cancel the roots, therefore we have y to be equal to plus or minus 15. Therefore we conclude by taking the positive one that y equals what? 15. Now when you are done, you have to come and put y back. You have to come and put what? Y back. Now, once you have now gotten all the sides of the what? The right angle triangle, we are now going to find the cos theta and the what? Tan theta. We are going to find cos theta and tan theta. So, cos theta, cos A, sorry, cos A, which you are finding cos. So cos is square, which is adjacent over hypotenuse, which becomes 8 on 17. But they said A lies in the second quadrant, and in the second quadrant, as we learned in the previous lesson, is the only side that is what? Positive. In the first quadrant, all the cos ratios are positive. But in the second quadrant, it's only what? Side that is what? Positive. So meaning, whatever you find in the second quadrant, other than sine, it will be what? Negative. Therefore, cos becomes what? Negative. Then tan theta, in terms of the angle A, becomes, well, which is opposite over adjacent. So opposite over adjacent, which becomes 8 on 17 and 8 on 15, sorry, 8 on 15. But note that in the same tan is negative. Sorry, cos is tan. As we are depending on this, which is adjacent by hypotenuse, meaning cos is what? Adjacent to our hypotenuse. So this one rather is 15 over 17. So we replace it back because cos is tan, which we are depending on this. This means cos is equal to adjacent. Our adjacent here is what? 15 over what? Hypotenuse, which is what? 17. So that's it. So you can visit more textbooks for more examples and solve. Now, if you have any other questions, you can post it at the comment section for us to review it together. Now, without wasting much time, let's look at the basic identities. Basic trigonometry identities. So that's the next subtopic. The next subtopic. Basic trigonometry identities. Basic trigonometry identities. And what is that about? So in the basic trigonometry identities, in our first lesson, we learned that we have our Cartesian plane, which is bounded by a circle like this. And we know from here, in the middle of Cartesian plane, which is labeled O, which is the center. From the center to any part of the circle, which is our radius. Then we know that, and there was a right angle triangle. So which was labeled A, B, O. So from, we know that from O to B is not up to the circumference, so it's not a radius. And we took it as the S line, so here is S. And this one too, we label it as Y. So we have, and if we are to measure from here to this side, and he said, let's take that angle to be theta. So from there, we also came to deduce that, or we also saw that sine theta, sine of the angle, which is so, becomes opposite over what? Hypotenuse, which becomes y over r. We are just revising, then we have cos theta, which is adjacent over hypotenuse, which becomes x over what? R. Then tan theta, which is 2r, which is opposite over what? Axis, opposite over what? Axis, which was y over x. Now with this same idea, because we have right angle triangle, let's apply the law of Pythagoras, which says that the square of the opposite side plus the square of the adjacent gives us what? The square of the hypotenuse, which is r squared equals to y squared plus s squared. Now, this is a circle with our radius to be 0, or with our A and B to be 0. So if you visit circle, you get to know what I'm saying. When we have x to s minus the radius here, which are the value here, the circle formula, where we have y minus b squared equal to r squared. But here they say that the value for A and B are all 0. So that's why we are having this as a circle. So let's look at something. Now we want to now make the radius become 1. if now we want to reduce the ratio here to become 1, so what do? We say we divide 2 by r squared. So we are going to have r squared divided by r equal to y squared over r plus x over r. As you can break r square will cancel itself, giving here to 1 equal to, therefore we have y squared over r. We can still write it like y over r, all what? Squared, plus x squared over r squared. You can also rewrite it as x over r, all what? Squared. Then we go back to our basic ratios. We go back to our basic ratio. Which one is r over y? Y over r is what? Sine. Whenever we see y over r, we put what is sine theta. So therefore we are going to have 1 to be equal to sine theta, but this time around there's a square, plus, then we go back, let's see whether we have x over r. So we have x over r, which is cos theta. Square. Therefore, we are going to have 1 to be equal to sine squared theta plus cos squared theta. So this becomes an identity. Now note this one too, we also have their reciprocals. We've talked about their reciprocals as we learned from the previous what do you call? So this one, for instance, whenever you are solving and you have 1 to be equal to sine squared theta plus cos squared theta, you can replace it by what? 1. As well as you can also make sine squared theta the surrogate. So if you make sine squared theta the surrogate, you are going to have, so this cos square will go to this side. So it's going to be 1 minus cos squared theta, which means that whenever you are solving and you see 1 minus cos squared theta, you can replace it by what? Writing sine squared theta there. Because let's also, as well as you can also make cos squared theta. So cos squared theta also becomes 1 minus sine squared what? Theta. So therefore we have 1 identity. This one also becomes what? The second identity. This one also becomes what? The third identity. Now let's look at the reciprocals of this. We have cosecants, which is cosec. So when we write cosec, it is what? The inverse of what? Cos, which is the inverse of sine, which becomes r over y. And it was proved in the previous video, so you can also revisit that one. Then sec. Sec was also, sec theta was the reciprocal of what? Cos. So which becomes what? R over x. Then cos theta, which was also the reciprocal of theta, which was s over y. Now the reason why we should note these are the, let's say they are what? These are the 3 basic identities and their reciprocals are this. Now let's check. This is the situation where we wanted to reduce r squared to become 1. Now let's take the situation if you want to reduce the y squared to become 1 and see the identity that will come out from it. So it says we divide, so we have r squared equal to y squared plus x squared. So let's divide 2 by y squared. So we are going to have r squared over y squared equal to y squared over y squared plus x squared over y squared. So now we have r squared over y squared. All of them are squared, so we can rewrite it as r over y all squared equals then y will cancel itself, y squared will cancel y squared, giving here 1. Then plus x squared over y squared, all of them are squared, so we can rewrite it as x over y all squared. Now that we have gotten this, we are going to look at all the ratios and check. So when we have r over y, let's see, r over y is not here, but let's take the reciprocals. When we have r over y, it is what? Cosec. So in place here, we put cosec there. Cosec what? Theta. Or what? Square. Equal to 1. Plus, then let's check when we have x over y. So x over y also is what? Cot. So which is cot theta or what? Square. Therefore we are going to have cosec square theta equals to what? 1 plus what? Cot square theta. So this becomes an identity. This is identity 4. So whenever you are solving, if you have cosec square theta, or you have 1 plus cos square theta, you can put cosec theta there. Or if you have cosec theta, in place of this, you can put 1 plus cos square theta there. Let's also make cot the surface, cot square the surface. If you are to make cot square the surface, it's going to be cot square theta. Then this one will come here. This becomes cosec square theta minus 1. So this becomes identity 5. You can also make 1 the subject here. If you are to make 1 the subject, it's going to be cosec square theta. Then this cot will come and subtract. This will be cot square theta equal to what? 1. Then let's do the last part. So first of all, we have reduced the r squared to 1. We have also reduced the what? The y squared to 1. So we are going to reduce the what? The x squared also to 1. So what we do is that we divide through by x squared. Divide through by x squared. So therefore, I'm going to have r squared over s squared equal to y squared over s squared plus s squared over s squared. And as you can see, r squared over s squared, you can rewrite that r over s all what? Squared equal to y over x all what? Squared. Then the s squared will cancel s squared, so plus 1. Then we are going to look at the ratios. Each one is r over x. So r over x is sec. So we're going to have sec theta or what? Square equal to y over x. Y over x is tan theta. So which is tan theta or what? Square plus 1. So therefore, that is the master. We are going to have sec square theta equals to tan square theta plus 1. So whenever you are solving, and you have tan square theta plus 1, you can put what? Sec square theta. Or if you have tan square theta plus 1, you can put what? Sec square what? Theta. So let's also make tan theta the surface. If you have to make tan theta the surface, tan square theta the surface, this one will come here, which becomes negative. So So it's going to be sec square theta minus 1. If you also make 1 the subject, this theta square will come. So it's going to be 1 equal to sec square theta minus tan square theta. So these are the basic ratios that you know. Now without wasting matter, let's solve one example on it, then we call it a day. So now evaluate 1 over 1 plus sine theta plus 1 over 1 minus sine theta. So we have a question, so we should evaluate 1 over sine 1 over 1 plus sine theta plus 1 minus sine theta. So as you know, first of all, the first thing to use was look for the LCM. And the LCM is what we have. So it's 1 plus sine theta and then 1 minus sine theta. Then if you take 1 plus sine theta to divide this, it will cancel this, leaving 1 minus sine theta carry this, which will give you the same thing. So which we are going to have 1 minus sine theta. If you use 1 minus sine theta to divide the LCM, it will cancel 1 minus sine theta, leaving 1 plus sine theta. So you use that one to multiply the 1, which will still give you 1 plus sine theta. 1 plus sine theta. As you can see, if you have to simplify this sine theta is negative, which will cancel the positive. I'm going to have 1 plus 1, which is 2. Then let's expand the bracket here. 1 times the whole of this will give us 1 minus sine theta. This 1 minus sine theta. Then we take this one, sine theta times 1 give us sine theta. Then we are going to have sine theta times minus sine theta, which will give us minus sine square theta. So breaking it down, we are going to have 2 on 2. This sine theta will cancel this. We are going to have 2 on 1 minus sine square theta. So if we have 2 on 1 minus sine square theta. There is an identity that we proved that is saying that whenever you have 1 minus sine theta, it is so from our identity that we proved, we saw that cos square theta was equal to 1 minus sine square theta. So in place of this, we can put cos square theta there. So we therefore also 2 on cos square theta. Now we can remove. Let's factorize 2 out. I'm going to have 2 into brackets 1 over cos square theta. And we know that this is an inverse of cos. This is an inverse of what? Cos. And the reciprocal of cos will give us what? The reciprocal of cos will give us what? The reciprocal of cos will give us sec. So we know that this is the reciprocal of cos. That reciprocates cos. So the reciprocal of cos, the identity is sec. So, but here is first, you can't square theta. So, if you also want to know more, or if you don't understand this side, it's like this. Let me go through again. When we have the identities, you have, when we use this one, and we have our R on here, we have X, Y, and the other was here. We saw that it was adjacent over calculus, it was S over R. This was cos. So when you get to this side, after factoring 2 there, you are going to have 2 into brackets 1 over. So what was the cos ratio? Cos ratio is what? X over R. This X over R there. And note is square, so we put everything to square. Now we expand. So we expand the brackets. We are going to have 2 into bracket 1 over. We are going to have S squared over R. S squared over R. So which is the same as S over R squared. Which is the same as 2 into bracket 1 divided by S squared over R squared. So therefore put something 2 times 1 times. If you want to remove the division sign, times R squared over S squared. So you know the identity. When we have, so it becomes R over X all squared. So you go and check the identity, which will give you R over what? X or what? Squared. Which is therefore equal to, which mass of sec squared theta. But note, 2 is multiplied to it. So that's it. So try this one on your own and see what you get. So let's try this. So that one will be example. Let's do example 2. So example 2. Here, the previous lesson, you saw it together, but try it on your own. And this channel is for favorite math teacher. If you don't subscribe to